slowly. Typical. Yes, the network seems to be having a bit of an issue. Okay, so there we go. So you can see that this is a browser. At the top, we've got the normal sort of rendering component. That's just standard Qt WebKit widget. And at the bottom, we have the SSL errors. Now, in this case, there are no errors. But if I connect to my local machine, where currently I'm not running a server, you see I'm getting a network error. Nothing to do with the SSL, but we still need to handle that. Now, let's have a look at how that works. We've created the line edit so we can enter the URL. We've got a web view, and then we've just got a big plain text edit to show the errors. Nothing very interesting there. But the important bit is this. We access the network access manager that WebKit is using, and we connect to the two signals that are really important in terms of error handling. The first one is the finished signal. That tells us when the request is completed, but it's also quite important because that's the way we can use to access what certificate, etc. were in use. The other one we're connecting to are the SSL error signals. Now, if we look at what we're doing, for the finished signal, in this example, all we're doing is saying, was there a network error? Now, we just say, if there were no errors, we don't do anything. If there were, then we print network error and the error string. Now, that's quite a simple case, but we'll see something about that in a moment. Now, the more complicated one is dealing with the SSL errors. The thing to remember is there can be lots of them. So we actually need to iterate over a list of errors, looking at all of them. And if you're displaying them to the user, for example, you'll often have a list of different things that have gone wrong. Now, I've just set up a little test server here. So this is using an invalid certificate. It's using a certificate authority I've made, and let's see what happens when we connect with the application. Now, you can see here a list of different errors. The first problem, the host name doesn't match. That's a very common error, and a lot of libraries actually don't provide facilities for that for you. So, for example, if you're just using raw OpenSSL, there isn't anything for checking host names in there. We've had to implement that in Qt. The next is that the issuer isn't valid, so basically it's not from a trusted CA. And the CA isn't actually even trusted for this purpose. So we found the CA, but we don't trust them. Finally, we can't verify the certificate. But then strangely, you'll see at the end, we've now got a network error, which is that the handshake's failed. Now what happens is, after there's an SSL error, ultimately it all boils down to, are we going to allow you to connect or not? And if we're not going to allow you to connect, then the way we present that ultimately is as a network error saying the handshake has failed. Now I'm going to leave the test server running because we're actually going to be looking at that some more. Okay, so we've seen how we can deal with the standard situation of connecting to a server and making sure it's secure. Now, obviously, in a real application, you would present the list of errors a little bit more flexibly to the user. Applications were, in the past, tending to use a pop-up dialog for that. That's now recommended that you don't do it that way. The reason is that users tend to just click through dialogs and they don't even read them. I actually have a friend who is a very experienced developer. His site had a certificate that had expired. And even when he was doing a demo for me, he didn't notice that he was clicking through the SSL certificate error dialog. That's just how used people are to just clicking through these things. They just don't even see them. And so what people tend to do these days is in the content of the application, that's where you want to be displaying the SSL problems. And that's a much safer way of doing it. Now, as I said, people need to be able to click through the errors, or, well, not click through them, but people need to be able to suppress the errors. Let's put it that way. So sometimes you need to connect to things that don't actually do it right. Now, what you should do there is it should be the user's decision to do this. It should never be something that you decide for them. So you have to ask the user, and you get the permission to do so. And it's very important when you're doing it that you only accept the exception, or make the exception, for a specific host and a specific port. You should never, for example, just accept a certificate and then whenever you see that certificate in the wild, always use it. That's no good. You should never accept it and just allow it to be on any port on a system. That's no good. It really has to be both. If you don't, then it's just not safe. Yep. Well, there's the basic thing I'm trying to show you, or going to show through this talk, is that there should never be a normal situation where this occurs. So the way I'm going to show you how to do things, you could actually simply say, we'll never accept one. And that would be the best solution. But we need to give people, certainly within Qt, the flexibility to override that. My examples are going to show how basically every single standard situation where people think they need to allow exceptions, they don't actually need to, and we can do it safely. So I'm going to show you how to avoid it, but I also need to show you how to implement it because, well, I know for a fact that some of you aren't going to do it. So if we're going to have user exceptions, at least I'm going to show you how to do it safely. Yes. Any other questions before I? Okay, so we've got the exceptions. So let's have a look at how this actually works. Now, all of my examples are based on the exact same code base. So you're going to see everything that you're expecting. It's just going to be slight changes. So the first thing is we set up the network access manager as before. The finished signal, again, is exactly as before. But the SSL errors handling is rather more complicated. Now, because this is a demo application, I'm printing the errors as I did in the first place. But when we get the errors, I say, have we recorded an exception for this particular host and port? So I extract the URL, and then here I'm seeing if I've got a QMap basically that just holds a pair of the host name and the port. And what I'm recording is actually the digest of the certificate. Now that's basically a hash that says this allows me to identify the specific certificate that the user said is okay for this site. So here you can see this is how you can get the digest. So the SSL configuration class I mentioned earlier is accessible from the network reply, and that is telling us exactly what was presented by the server, and we get the peer certificate. The peer is the other end of the connection from the one your application is running at, and we ask it for the digest. We then say, does the stored digest match the one that the user recorded as an exception? And if it does, then we call ignore SSL errors. Now, ignore SSL errors is a supremely dangerous function. Ideally, you would never ever call it. And in my opinion, the only time you should ever call it is this one, which is when the user has specifically told you that they don't mind being insecure. If you call it in any other circumstance, or you make the decision for them, you're doing it wrong. It should never be the choice of the developer to call ignore SSL errors. So we ask the user, which we'll see, it's just a standard message box, not ideal. A really good implementation would present the user with plenty of information to allow them to make an informed decision, which they would then ignore and click yes on. This is why you should not do this. So we get the digest of the certificate again, and if the user's accepted the exception, then we insert it, and obviously we again have to call ignore SSL errors. So let's just see that working in practice. Now, let me just move that out of the way. Okay, so we can see that we've got the same errors again that we had before, and we need to make a choice. In this case, I'm going to go, yes, allow me to shoot myself in the foot. Now, we've then connected. Now, all this text that you can see here, this is it's a little standalone web server that OpenSSL provides for testing purposes. So this just tells us a little bit about the connection. It's not really relevant to the discussion. What's important is that we'll see that if I go to this site a second time, we didn't get the pop-up. That's because we've recorded that the users made the exception, ignored the errors. But you'll notice the SSL errors signal was still emitted because Qt doesn't know that we've recorded the exception. That's handled in your application. Okay, so now I've shown you how to do something stupid. Let's go on and look at how we can do things properly. So the first situation I'm going to look at is handling a development server. Now, developers are cheapskates, we all know that. Developers know they can make their own self-signed certificate, we all know that. So the problem is they do. They shouldn't. But what you should do is, if you're going to have a development server with a certificate that is not a valid one, that's fine. But make a certificate authority of your own, and then sign your certificate with your own authority. You shouldn't use self-signed. For start, it's just lazy and bad practice. But the problem is, people tend to leave the exception code in place in production. And so we see all sorts of situations where, as we saw earlier, the applications have disabled the SSL error checks because it was easier for the developer, and then they've deployed it to the user, and the user has now got no security, and basically you're the developers, it's your fault. So let's not do that to the user. But then you think, hang on a minute, don't these guys test things? Well, obviously not. Because if they were doing this properly, then they would have noticed this. And the really good thing about using a custom certificate authority is it means that you can test your error handling. You can test what happens with certificates, and you can actually go through the full process of a valid connection and an invalid connection, and it's actually the same code that you're going to be deploying to your users. So it's really only possible to properly test an application that uses SSL if you're doing it this way, or if you actually buy a certificate. They're the only two options. So let's have a look at somebody that does this. Once again, it's the exact same code, but with a little tweak. Fortunately, unlike the handling the exceptions, the tweak in this case is trivial. It's great. That code is all you need in order to handle a development server properly. What we've done is I've made a certificate authority of my own, and I'll show you a little tool to allow you to do that with a GUI in a minute. So I've made a certificate with my own authority, and I load in the CA certificate. I add it to the trust store. So we've got the method add default CA certificate. What that one does is take the existing trust store and just add one more certificate authority to it. And if we scroll down, you'll see we're back to what we had in the first place with the safe example. and there is no additional changes to handle this development server. And let's just prove that it actually works. So it's probably all getting a bit familiar to you now, but so a bit slow, but okay, we can see Gmail still works. We've got no SSL errors. Now, the interesting bit is test.site is just an alias for my local server on this machine. And I've forgotten to put the port in. Okay, so we can see there are no SSL errors. So even though I've not made a real certificate and no one would issue me with a certificate for test.site, everything's working properly. We've got no SSL errors. But how can I show you that the checks are all still being performed? Well, what happens if I just change the host name? We saw earlier that one of the errors we were getting with the certificate was that the host name didn't match. And here we go, we've got an SSL error. So what we can see is that even though I've made my own certificate, it's my own development server, we can test the SSL handling, and we're still getting our errors, but our dev server no longer needs to buy a certificate, everything works. So that's how you should do things if you're trying to do a dev server. But obviously there are more cases to handle. So we've seen we make a custom authority, we sign the dev server certificate, and then we add it into the trust store. And it's very important in this situation that you add it. If you replace it, then you break everything. But we'll do that in a minute. So the other thing that you get is if you're using a certificate authority like that, then you can have multiple dev servers and you sign them all with the same key. So that means that each one you don't have to do anything special for, and you can test 10 different services. The other thing you can do is it allows you to revoke the certificate. So if you have a certificate authority, that can say, actually, this one's not valid anymore. So next thing is, what happens if you want to connect to a bespoke service? So you're running a web service for your application, and you know that it's always going to be talking to your server, or at least it should be. Well, again, you could buy a valid certificate, you could get it signed, you could pay for it. That's a good solution. But say you want to do it on the cheap, or it's an internal service, so it's a bit of a pain. What you can do is just remove all of the standard certificate authorities from the trust store and just use your own. Yep. Sure. Yeah. Okay. That depends. Okay. Yeah. The question is, would it be better to add the CA certificate externally from the application rather than actually from inside the application's code? And the answer to that is often yes. Generally, if you're in a position to do that, so for example, say you're on a Windows network and you can deploy it by using Active Directory, something like that, you can just push it out to all of the machines that need it, then yes, that is a very good solution. That means that your code needs no modifications at all, and it will just work. The advantage of having it added in the code is that it's just easier to deploy in a lot of situations, so it's a convenience thing. As long as the certificate authority that you've created is handled correctly, and you don't, for example, leave the private key lying around, then it's fine to add it in the code. But yes, it's not as good as just managing the certificates properly. But the problem I've got is that I know people are lazy, and so I'm trying to show you how to do things in a convenient way, how to solve your development problems. And even though I'm a security guy, I'm trying to find a balance between the ideals of security, where we would, for example, have got a hardware security module for our CA key and things like that, and the convenience. So it's all about where you find the balance. Okay, So with a bespoke service, as I was saying, you again don't need to buy a proper certificate. You can just make your own. But in that situation, what you want to do is limit the authorities that you trust just to the one you're expecting. We'll have a look at how we do that in Qt. So once again, our standard example, and we'll connect to the test server. And you can see no SSL errors. Now, in a real application, this would be pulling off some JSON data or something like that. But here we're just using the same server. Now, as before, if we get the hostname wrong, just as an easy way of forcing an error, we can see it doesn't match, and we get the SSL error handling. But the really interesting situation is we try Gmail again, and here you can see Gmail's certificate is no longer trusted, and that's because we've removed everything from the trust store except the one we're expecting. So once again, let's look at the code. And let me just make that a bit bigger. And the code we've got is very small. Now, it's slightly more complicated than simply adding a certificate authority, but really it's just a little bit of boilerplate. The issue is that we expect a list of authorities. So we have to wrap up the certificate we load inside a queue list. It's not exactly tricky, but it means the code's a little bit longer. So we've got a list of certificates. We load our CA certificate, and then we just say set default CA certificates. So you can see that's different to the adding case, but it's basically a very similar thing. It just clears out the set and adds a new one. Okay. Now, the next situation we've got is broken servers. Now, this is something most of you probably won't encounter, but I thought I'd just briefly touch on it since it's a new feature that we've added in 4.8 and also in 5.0. The problem we've got is that a lot of people's SSL infrastructure is quite old. So particularly if you're talking about a bank, for example. So if you're writing a banking application and you try and connect to the bank servers, generally you'll be going through a thing called an SSL accelerator. And this is basically a box that's got a little bit of hardware in it to make the crypto go faster. Now, ideally you would think that because it's a bank, all their stuff would be great, but it turns out that's not the case. A lot of it is quite old. So you see an awful lot of SSL accelerators that claim to support TLS. So when the handshake is performed, they send back responses that indicate, oh yeah, everything's going to be fine if you connect with TLS 1.0. Well, unfortunately, it turns out that they're actually lying to us, and what they really support is SSL 3, but they've just sent back the response that claims they support TLS 1. And that all used to work because a while ago, nobody was using things called TLS extensions, and nobody was doing anything clever with compression. And so all these things were hidden problems. And nowadays, all of this stuff's getting turned on. And all of a sudden, we're finding all these banking applications don't work properly. So, you know, I test a lot of servers, and basically anyone who's got an SSL accelerator, the chances are that it's going to be broken in one way or another. Now, we've provided the set SSL options function, and there's various flags in there for turning on and off different sort of twiddly knobs inside the details of the SSL implementation. Now, in general, I'd strongly recommend you don't touch it. Now, we've tried to document it quite carefully, and we've set up the options by default so that we've tuned it for maximum compatibility, except where it compromises security. So an example would be we turn on a thing called secure renegotiation. You may remember quite a while ago there was an attack against SSL that they demoed it on, I think it was PayPal, showing a cross-site scripting flaw that could be injected into the SSL connection by a third party. Now, that's kind of bad, so we don't turn that one on by default. But in some circumstances, you do actually need to turn it off because you find the server just won't work. So we are providing you with a way to do it. But what you absolutely must never do is turn these things on first. So don't make your connection, don't set it up to be sort of maximum compatibility and hope it to work. Test it, connect, and then only in the event the connection fails should you retry with these options turned on. Now that's very important. If you look at, say, the traffic from browser, then you'll notice that they do exactly this. They'll connect, and in the event it fails, they'll fall back a bit, and then they'll continue. Now I'd recommend that you first try with the defaults, and then try turning off some of the extensions like compression, which actually we've had to turn off recently because of another attack on SSL. So the default in 483, for example, was to enable compression because it made everything go faster. Now someone's found a security hole in it. In 484, we've had to turn that off again. So these things are going to be evolving over time, and in Qt, we'll be tuning the options that are turned on to make sure that your application is secure by default. But obviously that doesn't help if you turn them on again. So basically allow us to set the default, and then you can then, on your second connection, turn it for maximum compatibility. Now, one thing you can do is regress down from TLS down to SSL3, which turns off a lot of the stuff. But that does introduce a security hole into your application, but it's a fairly small one. And if you look at what most browsers do, they do actually do that, even though it's a bit bad. But make sure you try the real connection first. That said, what you should never ever do under any circumstances is fall back as far as SSL2. SSL2 is broken. There is no reason why you should ever be using it. There's no reason why a server should ever support it, but unfortunately, sometimes people do. For example, if you're using an old version of Internet Explorer, say IE6, it's actually possible to force the connection all the way down to SSL2 simply by man in the middling well, you don't even have to man in the middle. You simply send resets to kill the connection. It thinks the server has failed to connect and then falls back. So, pardon? Okay. SSL2 was invented internally by Netscape and written by a guy who didn't know much about security. He got some things right, so he thought, well, I'm not going to design my own crypto. Good idea. And he got some things wrong. So, for example, he started building on the X509 infrastructure, which is massively complicated. He got the key material, so the public key and the identity material mixed together, and that's why we end up with certificates that contain a mixture of both. But more importantly, the actual protocol in the handshake is flawed, such that you can basically get into the handshake in a bad way. It's a bit detailed. If you really want to know the full details about why SSL2 is bad, there's a very good paper by Bruce Schneier, who some of you may have heard of, and he talks about it and basically slates it, to be honest. That's what caused SSL3 to be developed and ultimately led to the standardization on TLS, which was, again, the same thing, but tidied up a bit more with a few more little tweaks to make it a bit more secure. Now, one thing you'll notice is that if you do try and fall back to SSL2, it'll actually not work on half of your clients. The reason being that most of the distros these days are building OpenSSL such that the SSL2 support is compiled out. So you'll be trying it, and it'll look like it's going to work, and you'll find that actually nothing happens. So, even if you try to do it that way, you'll find that you're going to get really weird bug reports, and it will work on your development servers, and it'll work on some people's servers, and it'll just strangely fail on other people's. So basically, even if you try and do it, you're just causing yourself a world of pain. So, just to summarize, don't ignore the errors. That's a really common mistake. Okay, don't ignore errors when handling redirects. So, for example, a lot of people are implementing redirects themselves because we don't provide it in QNetworkAccessManager. And it's easy to, for example, to think, well, redirects are safe. They're really not. And you have to treat them with the same security constraints as any other connection. So what you need to do is not ignore SSL errors on redirects. Treat it exactly like you would when you're displaying the web page. That's a very common mistake. The other one you should do when handling redirects is don't allow redirects from one protocol to another. That's another mistake. So, for example, it's quite common for people to allow it to just redirect anywhere. And that causes problems when, for example, a malicious guy redirects from HTTP to, say, a file on the local disk. That can cause you with lots of problems. So you think you're connecting to a web server or getting content from a web server, and in fact you're getting content from, say, etc. password, which you then pass into your application, and your application then, say, posts it to Twitter. It's very, very easy for this kind of thing to happen. So if you've got a redirect and it changes protocol, the only one you should really allow is from HTTP to HTTPS. Everything else, treat with a lot of suspicion. Another common problem is failing to check that the certificate has not changed on a site where the user has made an exception. So that's a very common mistake. I see that all the time. Next one is forgetting that until the point when you've trusted the certificate is not yet trusted. Sounds a bit confusing, but the thing you've got to remember is when you're presenting the information to the user to say, do you trust this certificate? Don't forget, at this point, you don't trust it. It can lie to you. It can cross-site script you even. So it's possible to embed characters in the common name of the certificate, which is the bit you look at, to say, this certificate says it's valid for www.mail.com, for example. That might have a cross-site scripting attack in it. And if you're just writing content into, say, a web view and using that to present the error, then it's very easy to end up that you've just cross-site scripted it, the script executes, and it does a cross-site request forgery attack, and, for example, reconfigures your router. So Qt provides a function, Qt : escape, which is a terrible name, to be honest, but fixed in 5. In 5.0, it's got a better name, and it's more shiny and everything. But if you look on the Qt Labs blog, you'll see a post from Peter Hartman where he describes this attack and gives you some examples of the correct ways to fix it. There are also some other sort of slightly even more evil attacks that have happened that way. So, for example, putting dodgy Unicode characters into the certificate, putting null characters into the certificate. So there's all sorts of things that people have tried, and unfortunately most of the things that people have tried have tended to work. So just be a bit careful. For example, if you embed loads of new lines into the common name of a certificate in Internet Explorer, in IE6, the dialog means that the full string scrolls off the bottom and can't actually be seen by the user. So you put something that looks nice and safe at the top, you have a second common name that's got carriage returns in it, and you put a third one further down. So everybody gets this wrong. Please, at least try and get it right. We're providing you with the right tools, and just use them. And the final problem is an interface problem. Is a lot of applications, particularly in the mobile space, don't make it clear to the user when the data is encrypted and when the data isn't. That's very important. Now, there is actually a W3C recommendation on the user indicators that you should be using for describing SSL. So, for example, it's not just random chance that the browsers have all finally got their act together and used pretty similar indications of what's secure and what's not. They actually sat down and worked on it. And then, of course, mobiles came along and everyone threw it away. And so now we're in a position that we're back to square one. So at least try and make it clear to the user. And not just a little padlock in the corner. That's not really good because we don't know who we're trusting. The important thing is who is the person we're talking to. So if you look at Chrome, for example, they display the name of the party that you're talking to in the URL bar. That's a very good approach. Something similar is a good thing to do in your application. Now, I did promise that I would quickly show you how to make certificates really easily. I'm not going to do a full demo, but I'm just using a little tool called tinyca2. And it's, to be honest, I'd say it's probably a pretty evil hack. It's a Perl script that uses GTK, which obviously we don't like here. And it's running OpenSSL in the background in the command line and doing all sorts of horrible stuff. But it is easy. It took me 2 minutes really to generate the certificates that I needed for this demo. So, yes, I've got a reasonable amount of practice with certificates, but it's not hard, and it's a lot easier than messing around with the OpenSSL command line. And by default, it does the right things. So it allows us to make a test CA, which, as you can see, I've spelt wrong. I hadn't noticed that. And then we can just generate a certificate. So the one I used was the test.site certificate that you've seen. Status is valid. So it just gives you an easy way to do it. And then, obviously, we've got the key for the certificate as well. So I'd recommend using something like that. And it just avoids the pain of trying to use the OpenSSL command line directly. So the conclusion, Qt is secure by default. The only situation where you ever need to call ignore SSL errors is when the user has told you to. And ideally in an application, you don't. And you don't even need, in most applications, to give the user that ability. If you're supposed to be talking to your own server, then you're not going to use a self-signed certificate or set up an evil certificate. So generally, there is no reason to use it. And you can always do what you need without making things insecure. So basically, the take-home message is, if you're calling ignore SSL errors, the chances are you are doing it wrong. And these recipes show you how you can do it right and avoid the problem. So that's it from me. So any questions? Yep. Okay, the question is, would I recommend encrypting user data before sending it over an SSL connection? Now, the answer to that is not really. Encrypting things yourself is mainly useful in terms of data at rest. So when you've got something on the disk, for example, you may well want to encrypt it. But SSL is all about the transport security. So it's about getting things from one place to another. And in that situation, basically, if the SSL is broken, the chances are that your encryption is as well. The reason is SSL uses the standard algorithms, so AES, etc., which are exactly the ones you're going to use yourself. So if the encryption is the problem, then basically we've got a big problem, and the chances are that SSL will get fixed quicker than your application, because that will be, every browser manufacturer in the world, every bank in the world will all be throwing resources at fixing it. So in terms of transport security, no, I don't really recommend doing it yourself. In terms of encryption at rest, protection at rest of data at rest, where it's on the disk, then yes, it can be a very good thing to do. Okay. Any other questions? Okay. All right. Qt project now has a security policy. We're working on it at the moment. Those of you who follow the development list will have seen the recommendations we've put in place. So the idea is that we're going to have a small core team of people who essentially triage security problems whenever they're reported to us. And if you get a problem or you see a problem in the libraries, if you mail security@qtproject.org, it will go to the right people. And what we'll do then is we'll evaluate it and see whether it's real. We'll respond to you, obviously, and let you know that we've got the message and that we're looking at it. And the aim is that we will then bring in the relevant maintainer to the right section, or fix it ourselves if it's an area that we know how to deal with. We'll then notify you so that we can coordinate any release of advisories, etc. And we'll then post an advisory to the announced mailing list explaining to you what the problem is, what the impact is, what the attack vectors are, and ideally how to fix it. So for example, the chances are we'll make a patch available at the same time. We'll be coordinating with the packaging people who at the moment are mainly Digia for Windows and in terms of source packages, but also with the distribution contacts. So we're going to notify distribution contacts in advance so that we can have packages ready. We'll notify basically other interested parties who, you'll be able to ask us. This is all sort of in progress at the moment, but the idea is going to be that there'll be a notification list for people who package things up and distribute them. And you'll be able to ask to be on that list, and you need to provide us with some evidence that you need to be on it. So for example, if you work for Linux distro and you provide packages, then we will do that, and we'll notify you so that you can get your packages ready. And then at the same time, we'll be able to release the fix and the advisory and let everyone update at once. If you want to talk more about that, then find me or Tiago later, because we're basically the people who are working on it. Any other questions? Okay, well, thank you very much.